So when it comes to binomial theorem, its questions are often tested in conjunction with partial fractions. That is, often partial fraction questions often just have a part relating to binomial, but the fact remains that its importance should not be undermined. So, for example, we have this. The first part would relate to partial fractions. The second part would relate to expansion, that is binomial. So, let's start with the first part. We're asked to express this in partial fraction. This is what we have, and this is equal to a plus b over x minus 1 over x plus 2, as we learned in binomial theorem. So 2x minus 1 and x minus 1, x plus 2. We'll cross multiply, and thus we'll have ax plus 2 multiplied with b x minus 1 over x minus 1 into x plus 2. The denominators cancel out, and we are left with 2x minus 1 is equals to ax plus 2 plus bx minus 1. We'll use the cover-up method, which is easier than the comparing coefficient method for partial fractions. So, first of all, let's take x as 1, so this cancels out. Don't take these numbers mindlessly, but rather use your brain. So, we have this is equals to 3a, and this becomes 0b, that is 0. So, I have a is equals to 1/3. Similarly, when x is equals to, so this can, x is equals to minus 2 rather, so this cancels out. So in this case I have this and minus 2 minus 1 b. This turns out to be b is equals to minus 5 over 3. That's it. Again, this is not our answer. Our answer would rather be 1 over 3 x minus 1 plus, no, rather minus 5 over 3 x plus 2. This is our answer. Now, the second part relates to binomial expansion, but with negative powers. How with negative powers? This can be written as, just a second, 1/3. This would go up, and thus this would be written as x minus 1 to the power minus 1. Similarly, we have 5 over 3, and this goes up, so its power becomes negative, that is minus 1. So now we have to expand two things. Let's deal with the first expansion first. This one. Whenever you have to expand, just keep in mind the formula derived. That is this formula. Let's copy this. Or I wouldn't even mind. It won't take long if you just take 2 minutes in your paper and derive this. But eventually with practice, you'll memorize this, and I'd advise that you still write this on your exam paper. So when expanding x minus 1 and to the power minus 1, I realize that the constant should always be in the first place, first of all. So I write this as this. After this, I need to expand, and I will do that. Minus 1 to the power minus 1 plus nc1, so minus 1 to the power minus 1 minus 2 x to the power 1, and yeah, so I have minus 1 and minus 2. Using this part, I'm doing this a bit fast because I'm up to speed. I have practiced, but you guys might need to practice for this speed. Yeah, and then we had to expand till x cube, that is till here. So I still have minus 1, minus 2 and minus 3 into minus 1 to the power minus 4 into, I'll just shorten things up a bit. Alright, so this is what I have. Just a second. Alright, so I have minus 1 to the power minus 4 and x cube over, since this is nc3, 3 into 2 into 1. I'll simplify each of these separately. Thus, I'll get 1 minus, rather wait, this would be minus 1, this would be minus x, this would be x square minus x square, or rather just, yeah, minus x square, and I'll have x cube minus x cube, and this is my answer. Alright. Oh wait, this is not my answer because I still have to expand this thing. I'm only done with the expansion part. Then I have to expand this thing. For this 2, x plus 2 to the power minus 1, I realize that a constant should be in the first place. I write the constant in the first place, and then I simply expand using this formula. Alright, so I have 2 to the 2 to the power minus 1 and minus 1 to power minus 2 x. Then minus 1 minus 2 2 to the power minus 3 x square. This turns out to be 2 into 1 plus minus 1 minus 2 minus 3. I'll have to reduce the size, and this is so yeah, 2 to the power minus 4 cause minus 1 minus 3, and yeah, x cube. This is nc3, the term with nc3, thus 3 into 2 into 1. And then I'll simplify each of these separately. So I'll have a half minus 1/4 x plus 1/8 x square minus 1/16 x cube plus so on. Because it's not a complete expansion. You are only asked to expand till x cube, and you did that in this case too. So just a second, I'll move this down. And finally, we'll come back to the question. When you are asked to expand to x cube, you are asked to expand a partial fraction, not only the separate bracket. So, I'll come back to this part. Just a second. And I'll copy this down. I'll move this here. This is what I had originally. And then just substitute the expansion. So 1/3 substituting this expansion, I have this. Similarly, then I have a minus sign in between, so a minus 5/3. Then I substitute this expansion. Alright, so this would turn out to be half minus 1/4 x plus 1 over 8 x square minus 1 over 16 x cube plus and so on. And then once I have this, I just expand each of these terms separately. So this is the expansion of the first bracket x cube, and then expansion of the second bracket looks something like this. And a minus 5 over 24 x square, then a plus 5 over 48 x cube plus so on. Then this goes with this, so I have a minus half. This goes with this, so I have a plus 1 over 12 x square with x square, so I have a minus 13 over 24 x square and x cube with x cube, and finally I have 11 over 48 x cube. This is my answer. Alright, so this question is a prime example of how questions are framed in A level pure mathematics 3. So the first part, as usual, asks us to express blah 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 f of x in partial fractions. So first of all, write f of x down again, x plus minus 2 and x plus 1. And then equate this to the standard partial fraction expansion with 3 denominators. And finally x minus 1. And then, so notice that the first fraction lacks x minus 2 and x plus 1 when compared to the original denominator. It only has x minus. Thus, it will be multiplied by what it lacks. And then b has x minus 2. Thus, will be multiplied by what it lacks too. And similarly, c would be multiplied by x minus 1 and x minus 2 since it has x plus 1. I repeat, numbers will be multiplied by what they lack when compared to the original denominator. Just writing the denominators, and these denominators will cancel out with the original. This leaves us with a simple equation which you can write in one line essentially. I just copy this down and paste this. Yeah, just a second. X minus 2. And then just copy down the quadratic equation x square plus 7x minus 6 from above. Then I'll apply the cover up method since it is much easier and faster than comparing coefficients. So let's assume x as 2, so this becomes 0 and c also cancels out. That is, both a and c become 0 and 0c respectively. Thus we can find b. So we have 2 square plus 7 into 2 minus 6, and we have a 3b. And the value of b turns out to be, yeah, 4. Once we found b, let's take the value of x as 1, b minus 1 for now. So when the value of x is 1, so that what cancels out? Just a second. First of all, on the left hand side. So we have 2 on the left hand side, and then I'm guessing that the right hand side will turn out to be minus 2a after b and c become 0. Alright, and then a turns, and the right hand side turns out to be minus 2a, and thus a is equals to minus 1. When it comes to finding c, x would be minus 1. So we have 0 and 0b. The left hand side is minus 12, 60, and thus we have c is equals to minus 2. You can pause the video and trace it down with you. Then once you have the values of a, b, and c, we can write down f of x in partial fractions like this. And then when we take the denominators to the numerators, their powers become inverse. Now why did I do this? Because this will help me out in the second part. The wordings for the second part seem complicated, but appreciate the fact that it only requires you to expand till x power 4. That is x cubed. All the terms before it. The expansion is also given, and we only have to show that this would be the. So we have this as part 2. Since we are done writing f of x like this, so let's show the expansion with yellow. So the constant should be in the first place. So this would be minus 1 plus x. I'll just make arrows to indicate this too. And write constant must be in first place. So once I'm done with this, I can write this as a to the power n. Then I have a ncn x. Then I have a nc2. And then finally I have a nc3. So this would be 3 into 2 into 1. Let's write this as 6. And I have a minus 1 minus 4 and a x cubed. Then I have to expand this thing. First of all, write this as minus 2 plus x minus 1. This would turn out to be minus 2 minus 1. Then I have this. NC2 is this. This is NC3. Let's shorten this up a bit. And then after NC3, once I have NC3, it's simple minus 2 minus 4 and x cubed. Then I have 1 plus x minus 1 after shifting the constant to the first place. This will be 1 to the power minus 1. Then I have a minus 1, 1 to the power minus 2. I have a x. Then I have a nc2. After this, I have 1 to the power minus 3 and then an x or x square. After this, NC3. This is long but easy. After you have some practice, this can be one of the trickiest chapters for you or even the easiest chapters for you. It all depends on the amount you practice. And this turns out to be minus x plus x squared. Hmm, Wait a minute. I just forgot to write a simplified expansion in both these cases. That's messed up there. Just move this down a little bit more. I'll move this down too. Alright. So the simplified expansion for the first case is something like minus x cubed. This is the simplified expansion for the first case. Then for the second case, I have minus 0.5 minus 0.25x minus 0.125 x square minus 0.0625x cubed. Then for the third case, I have minus 3, no wait, it's 1 minus x plus x square minus x cubed. And this is what I have for the third. And then just be a chill guy and substitute these expansions back. That is, it would be something like, in the first case, this is what one would have. Then, just copy this down, paste this, shorten this up a bit, shorten this too, and before this I had plus 4. Thus, I write a plus 4 here. Then I have a minus 2. Copy this expansion, paste this expansion, and this is what I have. After I am done expanding, I'll simplify all these brackets, or rather just not remove these brackets, since there are too many numbers, and if you remove the brackets it might become complicated when simplifying it further. And just multiply everything by 2, so we can simply put a plus here, by minus 2 rather. So after everything is multiplied by minus 2, this is what we'll be left with. Then just simply add, so you have minus 3 plus a 2x, since this x cancels and then we only have 2. Alright. And then minus 3 over 2 x square plus 11 over 4 x cubed. You guys can check this out yourself too. Once we are done with the expansion, we can just leave it as shown. And once I have shown this, I can think of myself as the king. That's